Equipment operator basic. Alright, non-resident training course in equipment operator basic Navedtra 1401 14081. Equipment operator basic. Alright, we're on chapter 11. Dozers and rollers. Okay, Chapter 11, Dozers and Rollers. Dozers are known as a crawler tractor. It is used as follows. A primary mover pushing, pulling loads as a power unit with that operation as a dozer, earthwork operations, and demolition work. Rollers are compaction equipment used to above mechanical compaction of the earth materials required for project specifications. A variety makes the dozers and rollers used for the Navy and Naval Construction Force. Each operator is responsible for reading operator's manual to obtain detailed information about each make and model. The chapter covers general characteristics, basic principles of dozers and rollers operation. Alright, dozers are commonly known as bulldozers. It is a crawler tractor on which the dozer blade has been mounted. Dozers are usually rated by size and power. The pull develops at a drawbar expressed in pounds, as is drawbar horsepower. The drawbar pull is the greatest lowest transmission gear range, although the specification for the drives dozers may vary among different manufacturers. Maximum speed is seldom in excess of 8 miles an hour. The dozers are equipped with a diesel engine supported with a ground track assembly. The track assembly provides all type of terrain versatility due to long ground bearing pressure at track. Low ground pressure varying from 6 to 9 pounds per square inch has a distinct flotation advantage over the rubber tired equipment. Ground bearing pressure then varies from 25 to 35 pounds a square inch. Dozers are capable of operating efficiency in muck or water as deep as the height of the track for short periods of time. When the dozer is properly waterproof, it can operate in fairly deep water. Alright, caution. When working with water deep enough to reach the radiator, be sure to disconnect the fan belt. The fan blades hit the water while under power. They could bend or break off, possibly causing damage to the radiator. Additional exercise, extreme caution to ensure the engines do not overheat when the fan or water pump belts are disconnected. Alright, figure 11.1 is the dozer. Figure 1.2 side view with the crawler track as chassis. It shows the driver sprocket, the track assembly, the carrier rollers, the front idler, and track frame. Dozers can move from job site to job site under their own power at slow speeds. However, this is poor practice tends to shorten the operational life of the dozer. For the reason of the dozer should be transported by tractor trailer from job site to job site. Alright, track and track frame. The undercarriage of the crawler-mounted dozer contains two major components, track assembly and track frame. The undercarriage shows the positive traction along with efficient operations. Track assembly. The track assembly consists of the chain surrounded with the track frame, driver sprocket, and the links of the chain provided with the flat surface of the track rolls over the passover as they support the equipment. Track shoes and bolted outside of the chain links to distribute the weight of the equipment over a large surface. The distribution of the weight is ground bearing pressure. Your track chain, figure 11.3, shows the cutaway of use the section of the track chain shown internally, arrangement of the pins and bushings. As the dozer operates, the drive sprocket's teeth contact the track pin bushing, pull dozer along the track assembly. The pins bushings wear much faster than other parts of the track because the constant pivoting as track rotates and track frame. The pivoting results in internal wear of the both pins and bushings. As the pins and bushing wear in the track links, when it does the track should be adjusted to remove any slack. Alright, extensive wear on the outside of the bushing is good indication in your wear. Manufacturers have set the specification for the maximum wear allowed before the track has to be rebuilt. To determine the track should be removed with a rebuilding replacement. Measure the outside of the bushing and the track pitch length of the track. Measure outside of the bushing at the location in which it shows much wear with the used caliper and ruler shown in figure 11.4. Compare this measurement with the manufacturer's specification. Measure 11.3 shows 1. The spacer, 2. The master pin, 3. The cone disc seal washer, 4. The master bushing, 5. The track bushing, 6. The link, 7. The track pin, and 8. The cone disc sealer washer. 11.4 shows bushing wear measurements. 11.5 shows pull track width of the old pin and sprocket route and measure across 4 track pins. Track pitch and ruler tape measures for tightening the track. Remove any slack in Figure 11.5. Track shoes. Most common track shoes are Grouser shoe, shown in Figure 11.6. The shoe is standard crawler mounted Dozer. The Extreme Series surface track shoe, shown in Figure 11.7, is equipped on the crawler mounted Dozer that operate primarily in rocky locations such as rock quarries, coral beaches. Notice the Grouser and raised portion of the shoe is heavier than the one of the standard Grouser shoe. Alright, the standard Grouser shoe, and then the Extreme Surface Track shoe. Note the Grouser absorbs most of the wear when the condition can indicate what the track needs to replace or overhaul. Alright, track frame. The track frame serves as a framework support for the track assembly, rollers, front idler, recoil, spring, and adjusting mechanism. Track frame rollers. Two types of the track frame rollers are used with the track equipment. These are used to locate the portion of the track frame which support the weight of the Dozer mounted on above the track frame which support the track as it passes over the track frame assembly. Figure 11.8 shows carrier rollers, track carrier rollers, paired out on the right, and then the single flange on the front on the left. Track rollers are mounted on the brackets extend from the track frame 11.8 with the two of these rollers each side of the Dozer. The single flange of the roller extends up between the links of the track chain, keeps the chain in alignment between the driver sprocket and front idler. Track lowers support the weight of the weight of the Dozer, ensure the track chain alignment with the truck and the frame it passes under the rollers. Figure 11.9. Track rollers, both single and double flange, are installed. Track rollers, drive sprocket, front idler. Alternately, in a normal arrangement, the double flange roller is positioned directly in the front of the rear drive of the sprocket fob with the single flange roller. Rollers that alternate forward in the front idler. Your front idler is shown in the Figure 11.9. Serves as a guiding support for the track of the chain. The idler spring loaded with the mounted on the slides guides, and that allow it to move back and forth inside the track frame as the Dozer passes over uneven ground. Spring loading efficiency causes the idler to maintain desired tension regardless of the operation condition. Your recoil spring is a large coil spring placed within the track frame. The way that enables the spring to absorb shock with the front idler. The spring then compressed with the insulation held in place in the stop and space for the track adjustment mechanism pressing against the spring stop maintains desired tension on the track assembly by the holder idler yoke in the forward position. The operating with the coil spring depends on the amount of the tension on the track. Track adjustment mechanism. The adjusting mechanism must be extended enough to remove the slack from the front idler spring. The adjustment is made either manually, Figure 11.2, or hydraulic, 11.11. Old model Dozers have many adjustments, whereas new Dozers are adjusted hydraulically with a grease gun. Grease gun is pumped and the yoke cylinder extends into the enough tension to play for the recoiler spring to move the slack from the track. Tension is relieved by loosening the vent screw located with the new adjusting fitting. Alright, 11.10 shows manual track adjustment. Figure 11 shows hydraulic track adjustment. Note, do not lubricate the fitting with a performing daily operating maintenance. The track adjuster fitting should only be greased when the tracks will require adjustment. Track adjustment. Determine the proper track tension. Position the Dozer on the hard surface and place a straight edge over the front of the carrier roller idler with the slack removed from the rest of the track. Tension is corrected with the measured distance shown in Figure 11.12. 11.12 shows 1 and 1/2, 1 to 1.5, and 1 to 1.5 straight edge. The track tension should be suitable for the type of the area arc working, so the tighter that the rock and looser in sand and snow. However, the tracks are adjusted too tightly, will be too much friction between the pins and bushings when the track is linked swivel as they travel around the sprocket. Front idler friction causing pins, bushing, links, and sprockets idler to wear rapidly. Friction tight track also robs the tractor's needed horsepower. Alright, tracks are looser and fail to stay aligned, tend to come off with the track as trimmed. As a result, the idlers and roller flanges side of the sprocket teeth will wear down. The loose track will whip at high speeds, damaging carrier rollers and their support. If loose enough, the drive sockets will jump teeth and slide over the track bushing when the track moves in reverse. Should this happen, the sprocket and bushings will wear rapidly. Note, checking when performing track adjustment are the operator's responsibility. Lubrication, track pins, and bushings are hardened and require new lubrication. Many roller ideas when equipped with a lifetime seal with a filter during the assembly require no lubrication. However, the track rollers, carrier rollers, others are equipped with grease fittings must be lubricated with a schedule based on the manufacturer's specifications. Note, fittings should be cleaned before lubrication to prevent forcing dirt and grime into the bearings. Attachments. The most common type of the Dozer attachment is the Dozer blade in a heavy rectangular steel shape. This is on. Alright, this shows the cutting edge for the corner bit. The corner bit's the cutting edge in the blade. Shows 11.4, the Dozer pad, Dozer blade pushes and pitch arms. Blade, push arm, pitch arm. On the front of the crawler tractor, you have the drifting pushing straight ahead with the side casting pushing one side material, other attachments including rippers and winches. Dozers and blades, cutting edge and corner bits are bolted with the bottom of the blade. Remember the checking the cutting edge for the wearers and operator's responsibility. The blade is connected with 2 push arms, 2 pitch arms, as shown in figure 1114. Most push arms are attached to the bottom of the blade outside of the track frame and the truing unit 1115. On dozers equipped with the angle blade push arm C-frame configuration. The C-frame is attached to truing units wrapped around the front of the dozer. The blade is attached to the C-frame with a seal pin. Alright, 1115 shows the push arm truing unit. 1 is your cap truing unit. 2 is your bolt cap. 3 is your truing unit. 4 is your C-frame or push arm. 5 is your cap screw truing unit mounting. Figure 11.6 hydraulic pitch arm shown in the picture. Pitch arms are diagonal between the push and the top of the arm and the top of the blade. The brace blade against the loads have push arms provided means regulating the blade pitch and tilt. The push arms are threaded, but they have the hydraulic cylinders shown in figure 11.16. To pitch the blade forward, length of the arm forward blade pitch on the dozing extremely hard materials pitch blade back and shortening the pitch arm of the pack blade pitched with a good leveling, spreading, cleaning loose material without blade digging. Tilting is done shortening one arm and the length of the other. Straight blade. The straight blade, figure 1117, is an ideal general dozing when the materials are. Figure 1117 shows a straight blade. Figure 1118 shows an angle blade. And figure 1119 shows a U-blade. The different short and medium distance blade curvature and the dirt, higher rolling action, lower resistance, speed differing. Drifting the blade, it has the side advantage ahead of the center section, tilt up 15 degrees to the right and left. Alright, your angle blade, figure 1118, multiple purposes can be used for the general dozing and for side casting materials. Angle blade can be positioned straight ahead and angled 25 degrees either side. The mold board has a greater curve than the straight blade, producing more rolling action. Your U-blade, figure 1119, drifts the large volume loads efficiently on the long distance center section, left material higher than forward roller. Alright, the side section is angled with the lift and the roller materials inward, keeping the lower center in the minimum loss material of the side. The type of the blade has the sides and well advanced over the center section U-shaped and may be lifted, tilted 15 degrees right or left. Alright, figure 1120 is a ripper attachment, and then figure 21 shows a winch attachment. Ripper attachment is mounted at the rear of the dozer. Figure 1120. Ripper is powerful tool used to break apart and compacted materials, uproot boulders, stumps, and loosen shale, sandstone, asphalt, pavements, and right up concrete slabs. After these materials are uprooted and ripped, they can be removed easier by supporting equipment. Note, care should be taken when turning the ripper teeth into the ground because of the damage for the ripper teeth that suddenly can occur. Alright, winches. It is mounted on the rear of the dozer. Figure 1121 is directed gear of the rear power to take off the arrangement permits the development of the line development line pull that has 50 to 100% greater than the straighter dozer pull. The winch is used to upright and retrieve the stump, hoisting, skidding, felled trees, freeing mired equipment, supporting amphibious construction operations. Some limitations considered when winch operations are pulling capacity. Winch the same size as the weight of the dozer. Also, terrain may affect the maneuver of the dozer. Warning, the breakage of the wire rope is seriously hazardous to both the operator and the helpers. Wire rope stretches under strain. If it breaks, the whip is with great force. The danger to the operator, the greatest to operate a dozer in the area in direct line with the wire rope. When it's under strain, the wire rope is under strain. Everybody in the area should stand clear of the full length of the paid out wire rope. When winding the wire rope back into the onto the winch drum, ensure the rigger's hands are clear of the winch drum at least 3 by 3 feet. By safety conspicuous, ensure the wire rope used in the best quality meets the manufacturer's specification, properly inspected before use. Always wear leather palm gloves when handling wire rope. Alright, good practice to work with the winch in less than the maximum capacity to avoid anchoring the dozer unless absolutely necessary. Mounter loads given life of the wire rope winch parts and avoid severe catching with the drum. Working with heavy strain can be required. Reduce the use of pulleys and multiple lines when pulling the winch. Always be sure to pull straight off the winch when the wire rope is pulled off for an angle to slip sideways. Possible cause damage to both the wire and winch. Operating techniques. The dozer blade and the hydraulic controlled by a lever to the operator for the cab before starting a rave. Lower the blade several times to reveal the hydraulic control. Start a all job if possible from relative level ground, if necessary level and area large enough to provide sufficient workspace for the dozer, prevent back and forth pitching of the dozer and result in better blade control. Avoid track spinning whenever possible. The waste of the effort that only converts relatively smooth working areas into rust piles of the material into that a pitch till the tractor in cold weather ruts and piles of freeze cause additional difficulty following workday. If it rains, ruts hold the water, resulting in wet, muddy material. Ditches, ridges, rocks, logs should be crossed slowly and possible if at an angle. If the procedures show the fall and less of the danger of upsetting the dozer, reducing jolt from the fall with the harmful for the both the operator and dozer. When dozing, shifting dozer into the lower gear of the head of the blade of the ground gradually until the desired depth of the cut is obtained. When you feel the increase of the resistant load, increase the straight raise in the blade. Small increments about 1/4 of each inch at a time. If you raise the lower blade as much as 2 to 3 inches at a time, while operating the blade cuts an uneven surface with it which the dozer must travel. The uneven surface will cause the dozer to nose up and down. This will cause the blade to cut still and more unevenly, thereby increasing the upward-downward movement of the dozer. Alright, to carry out the load with the blade, you must anticipate the compensate up and down movement of the front of the dozer. Front dozer start the nose up. You should move the control lever into the direction of the lower blade. The dozer starts the nose down. Raise the blade in high enough to compensate with the lowering of the front of the dozer. Don't over control it. Raise and lower the blade and only enough to compensate with the raising and lower of the front of the tractor. Through experience, you will be able to raise and lower the blade automatically without giving it much thought to special intention. Alright, clearing consists of removing the brush and tree of the rubbish and the designated air surface bowls or other material that may be embedded within the ground should also be removed, as well as the material that may interfere with the construction project. Brushes and trees. Should clear brush and small tree with the dozer, travel forward at slow speed with the blade to lower several inches below the grade as shown in figure 1122. When cleared with a sprayer, make one pass to knock over the small trees and brush, then make another pass to clear them away. Medium trees about 4 to 10 inches in diameter to the push the trees in size, raise the blade as high as possible. Figure 1122 shows the clearing of the bush of small trees. 1123 shows pushing over a medium-sized tree. To gain a leverage, push the tree slowly as shown in figure 1123. All trees fall back up quickly to clear the rising of the root mass, lower the blade forward and travel forward, dig the fruits free, with the lifting of the pushing action felled with the trees readily to push in dismissal area. Large trees are over 10 inches in diameter. From large trees, removal is slower, more difficult takes the more time. Approach the tree in front with inspect with the dead limbs that could break off and then fall on the dozer, possibly hitting the operator. To make sure the dozer blade contacts the tree high centered on most of the leverage, before pushing over the large tree, determine the direction of the fall, which are usually the direction of the lean. If the tree can be pushed over in a manner described, the medium trims do so. Alright, the tree has a large root system. Follow the method using the cut made up the side opposite direction of the fall. Tree deficient to cut the sum of the large roots, figure 1124A. The roots of both adjacent sides are cut similar to figure 1124B, and build an earth ramp above the original cut so the greater pushing leverage can be obtained to push the tree over in 1124. Alright, 1123A, 1124, 24B. And then there's a ramp on the C. Alright, caution. When removing, be careful not to injure personnel, damage equipment. See, the dozer has side coverage for the engine. These coverages help to prevent limbs, sticks, and other debris entering the engine area. Dozers should never be worked close together when clearing the trees because one dozer could push the tree over on the other. But don't follow these. Do not follow too closely when the tree starts to fall, since the stump may catch under the front of the dozer. The dozer then will need to back off and be backing off. The bottom of the dozer could damage. As the operator, you should have a plan on how you're going to accomplish clearing the trees so that they do not tangle with one another when they fall. The problem when pushing the green tree with the bending and the snapping back of the frame may damage the equipment, injury personnel when making contact, releasing pressure on the tree. Do it slowly. The top of the trees do not sway and shake, causing dead limbs to break off and fall on the dozer, possibly hitting you. Now, knowing the ground on which you are working, do not high center of the dozer on the stump of the tree. The problem is tougher than working in the wooded area and need help with the front aid. Another dozer, existing trees could interfere. When you're climbing brush or trees, remember the most common cause of damage to the machine, stake or limb, puncturing the radiator, breaking the hydraulic line, damaging the exhaust stack. Pay attention to know the capability of your dozer when you need to form or from the start to finish. Alright, stumping. Pushing down on a whole tree with a dozer is either removing the tree first, cutting it down, the removing of the stump. The stump is usually too short to gain any push leverage or to provide swinging action for breaking out of the roots. When removing a trum side cut deep enough to get the blade under the roots, and when we break up the roots, replacing the blade well underneath the stump, travel forward and raise the blade. For the stump will not yield, dozer housed in and out of the chain grab hooks pulled to several dozers. Many work on some stumps may held out of the wire leading of the winch equipped dozer. If the ground or stump is not disturbed, you may only need to saw stump off level with the surface grade and rather than removing it. Alright, moving rocks and boulders. Is a dozer tilted blade most effective piece of the equipment to moving the rocks and boulders with the left lower corner of the bucket blade hooked well under the boulder? The most best way to exert maximum operating pressure is to raise the blade with the right turn of the dozer. The right lower corner of the blade look well under the bulldozer. This best way to exert maximum uprooting pressure is to common raise the blade left turn of the dozer. The boulder that is deeply embedded should be beside the cut like a stump. Some of the boulders, like stumps, must be broken up. Some of the other way to remove it. If the dozer is not equipped with the hydraulic tilt, the dozer blade can be tilted by adjusting pitching brace of the blade of the dozer. Lower either the corner blade to increase the digging and an actual straight blade dozer when working a hard ground on top of the blade forward. Alright, working in wet material. Wet material is quite difficult to move a dozer. When the material is so soft to hold up the weight of the dozer, excessive passage should hold the depth of the material. The bulldozer is firm footing of the mud should push on far enough to slow it and not flow back into the cut and provides rescue for the dozer if the dozer gets stuck. No, never pull a dozer forward and hooking onto the blade. The blade is made of pushing, not pulling. The hook towing the wire rope and hook up under the front of the tractor, drawbar rear of the tractor, on the rear of the tractor. Some Dozers are equipped with wider track shoes with better flotation working in the mud or soft materials. These tractors, wide track shoes, are called low ground pressure tractor. The extremely low ground bearing pressure is one of many reasons the Dozer is highly recommended for working wet materials. Alright, bulldozing. Drifting is process of pushing material straight ahead with the front of the dozer blade. Bulldozer's most efficient push is the material as possible, shown in figure 1125. Maximum work distance for dozer production depends on the speed and capacity of the dozer. However, the maximum working distance is usually 200-500 feet, with 300 feet being the normal for a medium-sized dozer. To maximum amount of materials pushed and downhill whenever possible, assistant of the gravity bulldozer pushes the far greater load downhill than a level grade. When the dozers are down steep hill, the separate full length passes each load unnecessary intended to push and pile several loads at the break over the hill and push them all at the bottom in a single pass. Figure 1125 shows bulldozing. 1126 shows side-by-side bulldozing. Alright, and then figure 1127 shows slot dozing. Side-by-side dozing or slot dozing, maximum amount of earth drifted by the reducing, preventing slipping around outer edge of the blade. Side-by-side dozing. Side-by-side dozing, two dozers are work abreast and blade edges close together as possible to prevent slippage around one blade and on each of the dozers. Side-by-side dozing requires time-consuming maneuver of the dozer, therefore in practical hauls less than 50 feet or more than 300. Alright, slot dozing. Slot dozing is done first by building a pair of windrows or spillage of several passes, as shown in figure 1127. The windrows serve the barriers to prevent slippage around the dozer blade ends in unfavorable conditions. Slot dozing can be increased production up to 50%. Alright, 128 shows spreading, and then 129 shows a culvert backfilling. Alright, spreading. Dozers are ideal spreading field when the material brought to the hollow unit with a positioned blade with a straight position so the material is drifted into the cutting edge or the cutting edge. Backing is process for the replacing excavated earth, shown in figure 1129. Culvert is backfilled with the dozer should not cross the culvert unless there is at least 12 inches of compacted material on top of the culvert. If the bulldozer is used in the back of the culvert, the best method is to make diagonal pass over the material, each pass with a swing that brings the blade in line with the culvert. The angle of the blade is preferred with the backfilling of the trench because the material can be side cast into the trench with maintaining a steady forward motion, shown in figure 1130. 1130 shows trench backfilling. When a pipe trench is backfilled with the filled material pipe placed around the pipe, coarse material above it, so the pipe is supported well compacted material. However, covering the pipe until full depth, the short length may concentrate the weight and break pipe joint. Therefore, all cover in pipe in successive layer rather than all at once. Note: be careful of the pipe trenching backfilling. Avoid drop large rocks directly on the pipe. Finishing: When clearing or spreading material on the roadbed, no job is completed until the best smooth drainage is established. This can be finished and should be done at the end of the shift. Blade job lightly with about half of the blade over the dirt, the fills, and any low spots or holes. Leave the windrow side of the working toward. At the start of the next path, cover the half of the blade width and continue the fashion over the project section of the project worked on the day before. You shut down for the day. Finish the project in this manner. Support the drains. Prevent having to walk over the piles of dirt and through the mud holes. Alright, ditching. Rough ditching can be done with a dozer by making a series of overlapping passes and right angles to the line of the ditch, and a V-type ditch can be dug with a dozer as follows. First, build a windrow along the edge of the V-ditch construction, angle blade ditch cut, 1133 bench cut, 1134 side hill excavation, 1135 shallow slope side hill excavation. Or the ditch in figure 1131 for the turning machine parallel line where the ditch gets the outside of the track of the window, passes along the windrow, the outside of the track elevated with the windrow. Blade cuts on one side of the V-type of the ditch, it cuts the other side of the same way. The angle blade is preferably ditching V-type of the ditch. Is two reasons. One, you can side cast the windrow in a single pass, and the angle blade will side cast the material side of the ditch as you travel along the windrow shown in figure 1132. Side hill excavation. Side hill excavation can be started more easily in a small bench cut that is made first, as shown in figure 1133. When digging the side hill, keep the inside uphill with the surface slightly lower than greater than tractor stability. Figure 1134, tilting the blade from the produces this type of cut. Figure 1136 shows finishing a side slope by working parallel to the right away. Figure 1137 shows finishing a side line working diagonally. Always cut the shelf wide enough to provide solid equipment for the use later. If possible, to move the material downhill to gain advantage in gravity to reduce effort to increase the stability of the dozer. On shallow slopes of the soft soil, the side hill cut can be managed from figure 1135 cuts 1 and 2. Stability increase with running uphill with the track of the insert. I had rigid left of the first cut 3 and 4 and 5 showing completion of the shelf, and then pushing the loose end material to the lowering side of the slope normally reduces the time required to complete the cut. Do not push the material beyond the point of required to retain the firm track and support. When you're backing up, do not raise the blade as to put the extra weight on the front of the idler's brake, causing greater track penetration. Left blade as you back away from the edge of the soft fills. Alright, the finishing side slope. Two commonly used methods for the finishing side of the slope of the dozer shown figure 1137 and 1136 and 1137. When side slopes are finished working parallel to the right of way of the figure 1136, the dozer starts at the top and the material each of the pass falls to the lower side of the blade and ends of the windrow. This is picked up on the seating pass and filling irregulation in the terrain. Do not allow the blade corner to dig since the step-ins for the slope beyond the job specification. Finishing side slopes by working diagonally, start the dozer at the bottom and work diagonally up the slope. Figure 1137, windrow informed and continually drifted into one side, tending to fill the spots of regularity. Alright, diagonally finishing the side slope, one with you, and as instant with the dozer may be used and efficient with a cutting upgrade. Alright, your push dozer. The push dozer here in 1138 is equipped with a push blade, however, in the most case with the straight blade dozer, the reinforced block in the center of the blade is used. Ensure the center line of the pusher and the scraper line. The alignment is not centered. It had to keep the push straight without extensive use of the steering clutch. When using the steering clutch, power is taken away from one track and the other track is doing all the work. If the scraper starts the jackknife, stop pushing it back up and reposition the straight with the scraper. Be sure the blade in the dozer does not cut the rear of the tires of the scraper and resulting in the downtime and costly tire repair. Placement. Dozer safety. Standard safety precautions that apply with the dozer operations are as follows. Only operate the dozer at speeds at which the dozer can be maintained at all times. Shows the 1138 shows push dozer. Alright, Navy safety regulations require all dozers equipped with the rollover to protective strictures, case guards, radiator protectors. All dozers purchased for the Navy are equipped with these devices. Dozers must never be used without these devices in place. Always wear a seatbelt when dozing. A sudden jolt with a working on uneven terrain can possibly throw you off the machine against the control levers, causing serious injury or death. Obtain digging permit before performing excavating operations with a dozer. When using a dozer demolition, take care of the preventing falling objects and striking the operator with the other personnel when falling. When felling the tree with a dozer, take care to avoid being struck with the falling branches or backlash of the branch or trunk. A dozer should never be used for clearing the tires without being equipped with the operator's protective cage, brush cage. Our personnel must never drive with a dozer drawbar, and dangerous practices have been cause of the numerous accidents. Operator with the dozer's represent should be made an effective effort to learn the locations of any underground high voltage electrical lines or gas lines that might be contacted by their equipment. Operate the dozer from sitting position, never from standing position. The dozer must be operated with extreme care when near the edge of the cut, where the edge may give the way with overturning the machine. A steep incline should be climbed slowly, gunning up the steep slope, as often is called dozer to overturn. Do not attempt to turn on the steep slope. Sliding sideways may not appear to be dangerous, but it can easily become so low side of the dozer hits a solid rock or stump. Coupling trailing equipment to the dozer is hazardous, especially alert with all this being done. Whenever the possible, equipment should be coupled with the dozer stop and the clutch if so equipped. Disengage and additionally set the brake and lower the blade when towing the heavy load with downgrade. Keep the dozer in low gear. Coasting is dangerous. A coasting dozer with a towed load is like a jackknife, likely to jackknife. Alright, before dismounting the dozer at the end of the workday, secure the dozer blade, lowering it into the ground. Lowering the blade prevents the dozer from lowering. More importantly, eliminates the possibility of the blade falling on someone whenever it's necessary to work on the dozer with the blade up, especially when the changing cutting edge of the blade must be securely blocked to prevent the falling accidentally. When required to protect personal protective equipment such as steel-toe safety shoes and hard hats, rollers. Anytime some soil is disturbed, it becomes expanded with very loose pack. During the construction of the fill and subgrade, the loose soil must be compacted into solid mass. The process and compression of the loose soil into the solid mass is called compaction. If the soil is not properly compared during construction, it will settle, causing the roads and building foundation runway to collapse, and soil may be compacted and naturally settled by the weather and time, and soils and poor settlement may be sped by soaking and allowing it to dry. This process is slow, cannot be depended upon to produce the high density required for the product specification. Another method of compaction is thoroughly chemical stabilization that involves the application of one or more chemicals to the soil to achieve the desired change in their characteristic. Mechanical compaction is normally required to supplement chemical stabilization. To accomplish mechanical compaction, you can use various compaction techniques. Type of compaction equipment such as vibrator rollers, pneumatic tire rollers, and steel-wheeled rollers. Alright, vibrator rollers provide the compacted force by a combination of weight and vibration. The steel compaction rollers, commonly referred to as the drum, they use for the compaction self-propelled and vary weight of the 7 to 17 tons. Propulsion single drum models is provided with the pneumatic tire wheels as shown in Figure 1139. Figure 1139 shows the vibrator roller. Drums and vibrator rollers vary from 3 to 5 feet in the diameter, 4 to 8 in depth, 4 to 8 feet in width. Engine provided power propulsion, also power for the hydraulic driven. The vibrating unit. The vibration is generated with the rotating eccentric wave within inside of the drum, and the speed with it determined with the frequency. Vibration permanent with the drum. The wave, the distance of the shaft. The eccentric determine the amplitude, the amount of the impact force. Both the frequency, amplitude of the vibration are controlled with the independent roller travel and engine speed. The vibration frequency of the roller is used for the compaction, generally between 2,000 and 3,000 vibrations per minute, depending on the model. Manufacturers, some models provide only 1 or 2 special frequency settings, while others may provide full range frequency for the certain limits. For instance, 1,800 to 24,000 vibrations per minute. Vibrator rollers achieve the compaction through the combination of 3 factors: weight and impact, the force of roller, vibration response in the soil. Weight is the natural force in the compaction soil. The vibration rollers amplify their static weight through the vibration to increase the overall dynamic weight. Impact forces are generated with the vibration on the compaction drum. They are regulated with the compaction frequency, amplitude of the vibration. The amount of the impact forces required to obtain optimum density depends on the type of the material being compacted. The impact forces also vary from the diameter of the drum and the width of the ratio of the roller stack weight and dynamic impact forces. Vibration response. Vibration in the soil material is the result of the wave of the forces exerted upon it in the vibrator rollers. Other types of rollers, the material may compact easily with difficulty depending on the moisture contact. Cohesion critical with a particular shape and texture. Confinement. For example, sandy soils require more vibration, less impact for amplitude. Soil with a higher clay cannot content requires more amplitude. The vibration becomes the needing of the action necessary to compact the clay with the vibrator roller, especially for the relative dynamic force of the material rather than static force used on other rollers. A frequency roller speed should be matched with it so that there is at least 10 downward impacts per foot with the travel over the roller. Speed of the roller increases with given the frequency of the vibration spacing. The impact grows farther apart. When using vibration equipment, keep in mind that the energy and part of the vibrator wheel must be absorbed. The material being compacted, controlling the amplitude permits the operator to vary from the force developed in the wheel. Therefore, the energy imparted with the material changing the lifting thickness. Material graduation may be adjusted with the amplitudes being used. The impact note is important for the roller vibrators only with the moving the vibration. Continue with the roller staying still and can change the direction of the vibration drum will leave an indentation in the material at the stop pointing must be. Modern rollers have automatic cutoffs with the vibration when the roller stops moving. The rollers used with the naval construction force are equipped with the two interchangeable drums, one known as the sheep's foot as shown in figure 1140 and the other known as the smooth drum as shown in figure 1141. The sheep's foot drum is usually with a compacting heavy, the 6 to 12 inches thick. Consecutive passes made with the drum the walk out over the ground and show the penetration of the sheep's foot decrease. The roller should only be used with initial compaction because the footprints they leave will not allow access to water to drain. These rollers concentrate static dynamic weight with a relatively small contact area of the sheep foot. The force exerted with the one row of the feet of the contact with the ground with all the roller weight concentrated on the row of the sheep's foot that they exert more than 20 pounds of force. Smooth drums in most heavy fills. Smooth drummer rollers work behind the sheep's foot drummer and grade and with thinner. 1140 shows the sheep foot drum. 1141 shows the smooth drum. 1142 shows the pneumatic tire roller. Lifted smooth drum is all with compaction equipment required. With the smooth drum compacts the lifts to 4 to 8 inches. Seal the surface to allow the excessive water to drain. Unlike sheep's foot drum, the smooth drum rollers to concentrate the full width of the drum. The total dynamic force is slightly less because the more of the drum is contact with the ground. Pneumatic tire rollers. Alright, pneumatic tire rollers are widely used with the compaction subgrade values for the bituminous for the mixture of the many of the type of the material they rubber than tire instead of the steel tires. Well, the drums generally feature with the two tandem axles wheel with 3 to 4 times with the front axle, 4 or 5 tires on the rear shown in figure 1142 that they align with the rear of the tires cover the space left between the tracks on the front tire. The tires are mounted in the pairs can they oscillate with the string singly in spring action, so tires can be done in the left into the soft spots that were abridged in the steel drum. The rubber tires have added with the downward pressuring the kneading effect with the materials to spread the tire the space between the tires. Pneumatic tire rollers can be balanced adjust with the weight depending on the size and type. The weight may be vary from 10 to 35 tons. However, the more important gross weight is weight per wheel and for the material being compacted. Alright, shows 1142 shows the pneumatic tire roller once again, and then 1143 shows the action of the pneumatic tire roller. Shows the center is up and down, the right is to the bank, left and the right, and the left and the right bank on the other side. Cause the pneumatic rollers ballast to the water at the top of the heavy and very unstable when operating with uneven terrain. (1144) Steel-wheeled roller. 1145 driving wheel rolling action. Pneumatic tired rollers may be equipped with 15 to 17 to 20 to 24 inch tires. Air pressure for the tires may vary with different type of the material, such as 50 to 60% psi of the final asphalt. Finishing asphalt with 100 psi compact with a granular sub-base. The tires must be inflated nearly actual. Equal pressure for the variation not exceeding 5 psi to apply uniform pressure during the rolling. 1143 shows the action of the pneumatic tires roller. When pneumatic tires are used because the individual wheel tires can exert kneading action in a small area with wide rigid steel drums tending to the bridge. Alright, your steel wheel rollers. Steel wheel rollers shown in 1144 is used for action finishing operation on base coarse material asphalt. The roller produces a smooth, solid surface under the favorable conditions, but the fail of the compact areas narrow within the roll due to the compact deeply in proportion to the weight. Steel wheel roller does not change the shape of the ring with suitable support for itself rather than sinks until enough bearing area to come in contact with the roller to support the roller weight. Driver wheels ahead of the tiller wheel is the direction of the travel. The tiller wheel functions as a steering axle. As shown in figure 1145, there is a downward vertical force caused by the wave of the wheel, and arrows eccentric with a steel wheel represent with the rotation force on the wheel. The force is transmitted from the base of the wheel as the roller Propelled with the concentric forces trying to move the weight of the material under the wheel rather than push it away. The forces result in the more direct vertical force than those forces under the tiller wheel. Alright, rolling technique. The roller technique is basically the same as any type of the roller. Some things you must consider for the steering, the direction, speed, and rolling sequence. Steering is sharply causing scuffing damage to the surface, therefore turns should be made slowly and gradually. You may have to pick up several times to complete a turn. Changing direction or speed, starting and stopping should be done gradually and avoid scuffing of the surface. Starting and stopping will ahead of the point of where you want to stop and gauge the direction of the control slightly to avoid any wheel spinning. Rolling speed of 1.5 to 3 miles an hour. You must develop a rolling sequence to ensure compaction is uniform through a fill. Our rolling sequence. Overlapping is part of the rolling sequence when the rolling deep the loose fill, but you have just overlapped the loose half of the drum with a gradual extension of the rolled material. In the unrolled area that makes the greater possibility of the concentration wake of local ridges, high spots, and rolling graded area with the side slope is shown with the crown back and bank road. You should work for them. The bottom of the top lower edge of the rolls have the tendency to push downhill, which can be best resisted by the compacted material. And working uphill, the creep of the soil away from the upper edge helps to preserve the slope. The crown road is according to the pattern shown in Figure 1146, starting at one edge, working in the center line, and moving diagonally to the opposite side of the work, and then center line from that side. And each of the re-rolling is done the same manner. In efficiency, the roll sections, as long as you can overlap the sections, is shown in Figure 1147. Bank sloped elevated curves that are rolled up in the direction traveled from the bottom of the low speed to the top is shown in Figure 1148. The rolling transition from the road crown to the bank curve is made with a diagonal from the center of the crown to the low side of the bank, and the rolling transition bank of the crown is made with a straight with the joining low side of the road crown. Alright, rolling should be continued until no compaction advantage is noted with the fill. With the successive passage, too much water in the filled material may make the compaction impossible. May require scarfing windrow to have the aerated with the material rubbery and spongy rolling action to fill the springs back into the nearly its original condition when the rollers have passed and indicated trapped water below the surface of the rubbery and spongy appear that may require stabilization on other means such as excavation area. Alright, shows the 1146 of the crown roller rolling sequence. Previous rolled 1, and then 2, and then 3, and then 4, and then 5 on the outside from the center, and then 6, 7, and 8 back into 8. And the starting section is here. The next section is 9 over there. Figure 1147, overlapping sections. Start of the section 2 with overlap of the section 1 and 2. End of the section 1, start of section 3. Overlap sections 2 and 3. End of section 2. Sequence on a bank curve 1, 2, 3, and then 4, and then back to 5 over 1, and then out of 5. Our placement, rewrap the soil cement with asphalt, stabilization, and so forth. Bituminous rolling. Most common compaction required for the bituminous construction achieved with the tamper for the asphalt pavement. Additional compaction, final surface texture achieved the applying rollers in the proper sequence. Hot mixtures should be at an optimum temperature for the rolling. When the roller starts to operate, the mat being laid, operator temperature should range between 225 degrees to 285 degrees. Rollers designed in bituminous operation are equipped with sprinklers that spray the water from the smooth tires and drums. When you're rolling bituminous material, the roller tires and drums must be moist and water to keep bituminous material from sticking. When water is not enough to keep the bituminous material from sticking, no foaming detergent is added with the water until the water has a soapy filling. Do not use a detergent that is designed to break down grease or oil. This will break down the petroleum products used in the bituminous mixture. Note, ensure the roller tires and drums are free of the debris and sand, dirt, and so forth before rolling hot bituminous mix. Caution, avoid prolonged skin contact with the inhalation with the vapors of bituminous operation. When using rolling bituminous materials, rollers should be slow, uniform speed with the diaphragm wheel positioned toward the pavement. The speed should not exceed 3 miles an hour. Steam-wheeled rollers, 5 miles an hour. Pneumatic tire rollers. Asphalt rollers must be kept in good condition, should be capable of being reversed and without backlash. Aligned rolling should not be suddenly changed the direction rolling suddenly. Reverse, thereby displacing the mix. To pronounce the change in direction should be made on a stable material. Rolling hot bituminous material is done by the following: transverse joints, longitudinal joints when adjoining previous plane placed in lanes, break down initial rolling, intermediate second rolling, finishing rolling. As guided with the longitudinal joint, edge rolling should be performed directly behind the paper. Break down rolling less than 200 feet behind the paper, the intermediate rolling 250 more behind the breakdown rolling, and finishing rolling as soon as possible behind the breakdown rolling. Transverse joints. When a transverse joint is placed next to any adjoining lane of the first path, it may be with the steel wheel roller moving along the longitudinal joint for a short distance surface and straight edge. Correction made if necessary. The joint is rolled with a transverse layout except for the 6 inches wheel width of the previous laid material, figure 1149. This operation should be repeated with successive passes. Figure 1149 shows the rolling a transverse joint, and boards for off-pavement movement of the roller, compacted material pavement, unpacked compact 6 inches roller. Alright, converting 6 to 8 inches of the fresh material into the entire width of the roll of the new mix. During the transverse rolling, boards are properly thickness may be placed at the edge of the pavement to provide roller with a surface driving at once as they pass the edge of the bituminous mat. Boards are not used for the transverse rolling must be stopped at 6 to 8 inches short or outside of the edge in order to prevent damage to the edge of the outside edge that may be rolled out during the longitudinal rolling. Alright, longitudinal joints. Longitudinal joints should be rolled directly behind the paving operation, only 4 to 6 inches for the width of the roller. Of the roller should be ride on the newly placed mix. The figure 1150 rest of the roller should ride on the previously compacted side of the joint. With each subsequent pass, more and more of the roller which is placed on the mix until the entire width of the roller is newly placed on the mat. When rolling a longitudinal joint with a vibrated roller, the roller drum extends with the 4 to 6 inches previously compacted lane, with the rest of the drum riding on the newly placed mat. The roller continues rolling along the line until the early compacted nearly joint is obtained. Longitudinal joints can be categorized as hot or cold joint. Figure 1150 shows rolling a longitudinal joint. Shows your roller and the compacted pavement at 6 inches and uncompacted mix. Alright, your hot joints. Hot joint between the two of the lane that they must mix at the approximately same time of the paper that's working in an echelon type of laydown produces the best longitudinal joint because both lanes are at near the same temperature when the roll of the material compacts single mass under the roller, resulting in little or no difference in density between the two lanes. When you're paving an echelon, the breakdown roller follower, the lead paper leaves the 3 to 6 inches unrolled edge of the second paper follows the second paper. The roller should stay as close as possible to the first paper to ensure uniform density of the tamed across the joint of the roller, following the second paper compact for the hot joint on first pass, figure 1151. Cold joint, a cold joint between the two lanes on which has cooled overnight and no longer. Figure 1151 shows the rolling hot longitudinal joint. Figure first lane and the second lane longitudinal joint is 3 inches approximately. Before joining a lane is placed because of the difference of the temperature between the two lanes with the difference of the density between the two sides of the joint. The longitudinal joint should be rolled directly behind the paver. Or breakdown rolling. Breakdown rolling may be accomplished in static vibrator steel wheel rollers. Breakdown rolling should be started on the low side of the hot bituminous mat, usually outside of the lane being paved, the bearing towards the high side of the region of this of the hot bituminous mixture tend to migrate towards the low side of the mat. Under the action of the roller, the rolling started on the high side. The mitigation is much more pronounced of the rolling progress from the low side. When they are joining the lanes of the place, and same rolling procedure should be followed only after the compaction of the longitudinal joint. A rolling pattern that provides most uniform coverage of the lane being paved should be with the rollers varying the width. The single recommended the pattern for the apply of the rollers is impractical. For this reason, the best rolling pattern each for the roller being used should be worked out and followed to obtain the most uniform compaction across the lane. The rolling pattern not only indicates the number of the passes, it also indicates the first pass of the sequence. Succeeding pass overlapping between passes rolling speed should not exceed 3 miles an hour. In addition, sharp turns and quick starts and stops are to be avoided. For thin lifts, a lift less than 2 inches compact, the thickness of recommended rolling pattern for static. Or the 1152 correct rolling pattern. The recommended with the rolling pattern, every path of the roller should proceed straight into the compact mix or return in the same path. After required passes are completed, the roller should be moved to the outside of the pavement and on cool material. Repeat the procedure. Or show the width of the rollers. That 1 and 3 about 3 one's pass there, 2 to the back, and then 3 the next pass, 4 to 4, and then then over to 5, and then back to 6, and then 7. Our steel-tired rollers are shown in figure 1152. Rolling operations should start with the edge of the hot mat on the low side of the roller, moving forward as close behind the paver as possible. Second move of the roller should be reversed in the same path until the roller has reached previously compacted material. At the point of aligning the roller past the number 3, and again staying close behind the paver. The fourth movement is reversal. Third path repetition. Third operation after the entire width of the hot box may be rolled in this fashion. You should swing on the roller back to the lower side. Repeat the process with the pattern each forward pass for the roller only needs overlapping previous roll before be area by 3 to 4 inches. For this thing, lift to 4 inches more compacted thickness. The rolling process should be 12 to 15 inches for the lower unsupported edge of the progress over the center portion of the hot mix. The unpacked edges provide initial confinement during the first pass. Minimum lateral movement of the hot mix. Central portion of the hot mix has been rolled and compacted. The compacted portion of the hot mix will support the roller, allow the edge to compact the lateral material. When using steel-wheeled rollers, the operation should always progress the driving wheel forward in the direction traveled. It's especially important the breaking down the rolling. The primary reason the breakdown rolling should be done when the driver wheel in the direction traveled, that there's more vertical load applied with the wheel by than the tiller wheel, figure 1153. If the breakdown path of the roller made with the tiller wheel forward, the pushing force of the weight are still slightly ahead of the downward vertical force, causing the material to push up into the front of the wheel. This greater weight of the driver wheels produces the compaction, while the turning force tends to tuck up the hot mix under the front of the wheel. The exemptions are with the rolling the driver wheel forward that usually occur with the super elevations being constructed, or if the grade over which the asphalt is being placed is excessive. The exemptions occur with due to these high grades. The driver wheel of the roller bearing has been shattered on the hot mat, causing the displacement of the hot mix, resulting in very hot rough. Figure 1153 shows forcing action of the tiller wheel and the driver wheel. Show the direction of the pavement, the wrong tiller wheel in the front, and the weight pushing force of the weight. Show the right direction of the front of the turning force and the weight. Alright, surfaces in these cases, the roller must be turned around and allow the tiller wheel to compact the material harshly so that the driver wheel can proceed over it. Intermediate rolling. Intermediate rolling should close following the breakdown of the rolling asphalt mix is still wet above the minimum temperature of 185 degrees. With the densification be attached. The pneumatic tire vibrator rollers may be used in intermediate rolling. Pneumatic tires rollers have several advantages. They provide a more uniform degree of the compaction than steel-wheeled rollers. They improve the seal near the surface of the kneading of the material close together, while they orient aggregated particles. Greater stability behind ground pressure trucks and tires do after the asphalt surface at some time. The tire contact pressure should be as high as possible, causing plate displacement that makes it that cannot be remedied in the final rolling. Pneumatic tire rolling should be continuous after breakdown rolling until the all mixes have been thoroughly compacted. At least 3 coverages should be made. No, turning pneumatic tires on the hot mix should not be permitted unless it does not cause undue displacement. Our vibrator rollers are the proper static weight with vibration frequency and amplitude are to provide required density, fewer coverage if it's static weight tandem. The pneumatic tire rollers or a combination of the two. Regardless of the type of the roller used, the rolling pattern should be developed in the same manner as for the breakdown rolling. The roller pattern should be continued until the desired compaction is obtained. Finishing rolling. Finishing rolling is done solely for the improvement of the surface. It should be accomplished with a steel wheel. A tandem statically weight with a vibrator over the hot mat is still warm enough to remove the roller marks. Roller safety. Many of the safety precautions previously listed for the greater scrape of the Dozers are applied with the roller operations. Added safety precautions are as follows. Never perform roller operations alone. Always have a safety person in the air of the rolling operation. Only operate the roller at speeds in which the machine can be kept under the control at all times. Always wear a scat below the rolling as well as the other required personal protective equipment such as steel show, safety shoes, and hard hats. Operate the roller over the sitting position. Never to have standing position. Use the safety handrails when mounting and dismounting the roller. Do not grab the transmission controller left with the mic up of the roller to make a sudden movement. If the roller ignition starts and any transmission push to break down neutral of the position, the machine should be hard-carded with the prepare before further usage. Alright, use caution when making sure the area is clear of the personal tools and vehicles when performing forwarding the reversing rolling operations. A roller is easier to overturn than most equipment. Rolling on the side slope, it should always be done at right angles diagonally rather than parallel to the slope. Steer carefully when rolling slowly to avoid capsizing into the ditch. Never bring it into the roller near the edge of the cut. Use extreme care with the loading of the steel wheels, rollers, and tractors or trailers during the periods of inclement weather. The wet deck of the trailer can cause the steel wheel roller to slip during the loading and the unloading operations. Alright, Chapter 12, Cranes and Attachments.